Okay, here we are, Stats and Mechanics, Year 1, Chapter 9, Mixed Exercise. Question 16. The car is being driven on a straight stretch of motorway at a constant velocity of 34 meters a second when it passes a velocity restriction sign S warning of roadworks, requiring the speed to come down to 22 meters a second. The driver continues at their velocity for 2 seconds. Okay, so we have the car coming down here, and it is at this point doing 34 meters a second. Okay, and after 2 seconds, okay, the driver, when it passes a sign S, so this is point S, okay, she then reduces her velocity to 22 meters a second with a constant deceleration of 3 meters a second. So she comes down at this point here after 2 seconds. She puts a deceleration on of 3 meters a second. Okay, 3 meters a second acceleration until she gets to 22 meters a second. Okay, at some point. Okay, and continues at the lower velocity. Draw a velocity time graph to illustrate the motion of the car after she passes S. So, as she passes S, she stays at a constant velocity, and then when she gets to T2, she drops down to a 22, and then she continues on at that. Okay, so in terms of the velocity time graph, it's going to look like that. Did they want it for after it passing S? So so it looks something like that, with this being point S, this being T equals 2, this being 34, this being 22, and this is velocity meters a second. Okay, and this is time in seconds. That's point S. It should be coming across there like that. Okay. Find the shortest distance before the roadworks that S should be placed on the road to ensure that the car driven in this way has had its velocity reduced by the time it reaches the start of the roadworks. So they are looking to see what the distance is in here at this point. So the roadworks here, they want to know what the distance is all the way through. So first things first, how far do we travel between here, okay, and then how far do we travel onward? So first things first, if we are doing 34 meters a second, I presume they mean we've still got this 2 seconds reaction time sort of thing. Okay, so presumably as we come through here and through here, okay, for this section here, the distance traveled is going to be the speed 34 times by 2, which is 68 meters to begin with. Okay, so that bit is 68 meters. Now the next bit, as we go from here to here, okay, we can put a suvat in place. Okay, we don't know the distance. The initial speed was 34. The final speed was 22. The acceleration was -3. Okay, and the time we are not sure of. So we are looking for the equation that has no t in it. So we are looking at v squared. Really don't like working in red. V squared equals u squared plus 2as. Okay, and then as we put it in, 22 squared equals 34 squared plus 2 times minus 3s. Okay, so 22 squared, 484, 34 squared when taken away gives us minus 672, so we end up with minus 672 being divided by minus 6 will equal s divided by minus 6, 112 meters. So the bit between here and here is 112 meters, so the minimum plus the 68 should be 180 meters. So min distance of S is 180 meters because we've added those two together. Okay, that's a lot, right? So I've just looked at the answers, and yeah, we're correct, but they have included the time down here. So we should really just show you how to find that. Again, we can use this suvat, but we want the equation that has no s in it. So v equals u plus at. So v equals u plus at. So the final velocity was 22. The initial was 34 plus minus 3t. So when we do 22 minus 34, we get minus 12. Minus 12, and that's going to be dividing by minus 3 for the time to give us 4 seconds. And of course, plus 4 seconds here would give us a t of 6 on that graph there. Okay, just to be a little bit more precise with it. Yeah, they did say draw, so you should do it rather than sketch. Okay, so my mistake in that point, but yeah, put in all the interesting parts of a graph. All right, next question.